Hello there! Let's solve another equation with radicals, but this time we have odd radicals. Let's have a closer look at our equation. We have a sum of 2/5 roots. As we know, there are no restrictions for odd roots, but under the roots we have fractions, and for fractions there is only one restriction. Denominator cannot be equal to 0. So we have two conditions. X squared is not equal to 0, and 3x minus 1 is not equal to 0. And these conditions actually give us the domain of this equation, which is x is not equal to 0 and 1/3. We can also notice that the second term of the equation is actually the first term inversed. So, to solve this equation, it is convenient to make a substitution. The fifth root of 3x minus 1 over x squared equals t, and the fifth root of x squared over 3x minus 1 equals 1 over t. Using these substitutions, we obtain new equation. T plus 1 over t equals 2. And as we have t in the denominator, we have an additional condition. T is not equal to 0. Now let's represent these two terms as fractions with denominator t. And let's move all the terms to the left. We get t squared plus 1 minus 2t over t equals 0, which gives us a quadratic equation t squared minus 2t plus 1 equals 0. This expression can be factored as t minus 1 squared equals 0, and the root is t equals 1. So we can see that t is not equal to 0. So we have t equals 1, and we also know that t is equal to this expression. So now we obtain another equation. The fifth root of 3x minus 1 over x squared equals 1. Let's raise this equation to the fifth power. We get 3x minus 1 over x squared equals 1. Here we should have considered that x squared is not equal to 0, but we already considered this condition when we found our domain. So let's just proceed. 3x minus 1 equals x squared. Now we move all the terms to one part of the equation and get x squared minus 3x plus 1 equals 0. So we obtained a simple quadratic equation. Discriminant of this equation equals negative 3 squared, which is 9, minus 4 times 1 times 1. So discriminant equals 5, which is greater than 0. So we have two different real roots. The roots are 3 plus minus the square root of 5 over 2 times 1, so over 2. As we can see, both roots with plus and minus square roots of 5 fit the domain of our equation. So this is the answer. Note that in this example we can fully benefit from finding domain of our equation first, because substitution of these roots in our initial equation is not an easy task. See you.